So SNIA, you have just released a new set of standards around a new type of storage product with the title Computational Storage Devices, or CSXs for short. Can you just give us a bit of an insight as to what's going on there?
Yeah, absolutely. The idea behind computational storage is a little bit of an advancement of some of the things that have been happening over the last several years. Specifically, what we have been realizing as part of the industry trends is that storage and memory are starting to become somewhat similar. And if you can have memory and storage using similar semantics or the same semantics, there's no reason why you can't have compute right next to it, and you can't have networking right next to it. So the ultimate idea here at the bottom line is that if you want to be able to do any kind of computing on data, it makes sense to have the compute as close to the data as possible. And there are a lot of scenarios where having data right at the compute processors makes a great deal of sense, because you don't necessarily want to move data from one place to the others if you don't have to, right? So even over a short distance, like you'd find inside of a server, any I/O that you don't have to send saves quite a bit more I/O in retransmissions, retiming, and that kind of thing. But more importantly, it allows you to put the processing capabilities where it's needed most. So sometimes you want to have processing on metadata. Sometimes you want to have processing on data itself. Sometimes you want to have processing in the control plane and so on. There's a lot of different processes that go on, but there's also a lot of different storage that goes on. Not all storage is created equal. So what you want to do is you want to find the right tool to place at the right job. What computational storage does is it gives you a series of options that allows you to do just that. I mean, for instance, right now people think of computational storage as a drive with a nice little processor on it. And while that's true, that is computational storage, that's not all it is. So storage is more than just data. It's more than just storing data. It includes all the protection that you have to make sure that you get the correct bit back that you ask for. It means that you have to have the services like encryption and compression and that kind of thing. It means you have to have the file systems being able to operate on all of these things that all work together to make storage have a wide swath of responsibilities. And placing them where they're best used is what computational storage is all about. Yeah. So it's at the very beginning stages of what's promising.
Okay. And I'm wondering, is that, I mean, everyone's been talking about the edge computing for quite a while. Is that one of the main drivers, or is that a happy coincidence that bringing compute and storage together, which I guess will make sense of the edge? Is it just a happy coincidence, or is it that people have been looking at it and saying, hey, isn't this a good idea? That's one of the major benefits, or as you've explained in many other places, it makes sense as well.
Well, it's kind of serendipitous. I don't think it was a coincidence, and I don't think it was necessarily by design. But I do think that when you get technologies that happen to evolve along similar timelines, you're likely to find those kinds of intersections. Now, any kind of edge computing situation, whether it be automotive, or whether it be mobile devices, or edge of a data center, all this IoT stuff that's been happening, and just the sheer amount of information doesn't necessarily have to be sent somewhere to be processed if it doesn't have to be. Some of it does. Sometimes you really do want to have massive collections of data to be able to do the kind of number crunching that a handheld device can't really do. But if you want to, let me give you an example of what some of the things you can do. So for instance, in machine learning, right, where you actually have to transform the data to be able to process it. You can't just do analytics on object storage, not natively, right? You have to make the data transform so that the analytics engines can use it. Well, what we normally have to do without any kind of computation on the devices is you have to send it somewhere for that pre-processing to be done. And then you have to run the models. But that first step, that pre-processing element, could very well be done at the edge, so that you're not necessarily sending all that data over into a centralized location. So one really good example for that is facial recognition software for cameras. So if you think about the way that that would work, you have a centralized server that does the processing for facial recognition. The camera sends the feeds back to that central location. That application starts to do the facial processing, and then it has to communicate with all of the different devices. However, with a computational storage solution, you could run the facial net recognition right on the camera and then only send back the information that you wanted to find, as opposed to just sucking in the ocean and trying to find that small little bit that you're looking for. So being able to do that kind of separation of duties is a major time saver, which of course saves processing power, saves cooling, saves network. You know, overall, the long term, it just does an awful lot of saving of energy and economics.
Okay, and then I mean, you've been very busy, so I'm aware as well. You've just published version, I think, 1.0 of the I'll have to read this, computational storage architecture and programming model. So can you give us you know, the background on that?
Well, in order to give vendors the general concepts that they want to use in order to develop a computational storage device, it helps to be able to understand A, what it is, B, what you can do with it, and C, how you can access it. So what this does is it provides a model of computational storage that allows you to create different form factors, that the nature of the relationship between a processor, the storage that it uses, the memory that it uses, and the corresponding form factors as come as a result of it. The APIs is simply a way of having a programmer be able to access a computational storage device to operate it from, you know, any kind of host or remote location. Now that's different than what's being done inside of the NVM Express group, by the way. I want to make it really clear that there's a separation. So the model and the architecture and the APIs are being handled inside of SNIA, and the commands for NVMe are being done inside of NVM Express. So the NVM Express is a slightly more narrowly focused version. It's really focusing on the drives at the moment, not so much the arrays or the processors or any of the kinds of broader flexibility. Like I said, we're at the kind of the beginning stage of this, but NVMe is responsible for their own command sets, their own theory of operation, which is outside the scope of SNIA. So we're working together with that organization to make sure that everything is aligned.
Okay, and just for us to understand, so with both the things we've covered so far, is it sort of vendors start producing these new types, you know, the new ideas, and then you get involved as, if you like, referee to come up with sort of open standards everyone can work to, or do you foresee or anticipate, you know, something coming along and then step in early? What's, just for people to understand, what's the you know, where does SNIA get involved at what stage?
Well, the ideas can come from anywhere. There really is no one way to start an idea, but the process of once an idea gets done, you get a couple of other companies or other members to think that, hey, yeah, that's something that's worth working on. And then if you get a critical mass, they come together and they start to identify, you know, what is it that we should do to make this work for the long term, for the long haul. I mean, ultimately, if you're looking just to have a solution that two vendors can work together, you don't need a standards body. You know, but once you get beyond that, you start to realize that I need to make sure that if I'm going to get a computational storage device from vendor A, and I'm going to get another computational storage device from vendor B, outside of the special sauce that they want to have to make it work, you kind of want it to be relatively similar in the structure, like the electric plug in your wall. You don't want several different plug sizes. You don't want several different plugs themselves. So at the very fundamental level, you have to agree on what that's going to look like. Now, that doesn't prevent you from being innovative by working, you know, to build on top of that. But in this particular case, you have a couple of companies who are trying to develop, you know, computational storage models that they're interested in, and so they get together with other companies who want to do this, and they kind of hash out the basics so that they can actually, you know, go onto the market and say, I have this device, and then the customers and the administrators will kind of have a general idea of what you're talking about. You know, for example, in NVMe, we started off with NVM Express for PCIe devices, and the whole purpose was that, You know, if you want to have, you know, that kind of really fast storage device, and you want to stick it inside of a PCIe slot, you don't want to have to rewrite a driver for every single thing that you want to put in there. Well, computational storage is the same way, right? You don't want to have a very specific solution for every single one that comes down the road, because quite frankly, there are a lot of different possibilities and options, and you got to have some place to start with. So in this particular case, you just have, we have 52 different members who happen to have a very similar idea, and they came together to start working on the specification.
Okay, and in I guess a slightly similar vein, I see that the DNA Data Storage Alliance have become an associate member.
Yeah, technical affiliate.
Okay, so and I'm just interested. I think there was a track on DNA storage in your recent Storage Developers Conference, but again, for those of us, myself included, that maybe aren't too up to speed on that, what is it, and is it as exciting as I'm imagining it could be?
I think it is, personally. I mean, I have to confess, I'm no biologist, so I don't really understand a lot of the very specific things, or chemist, I guess is probably the best way to, I don't know, it covers a lot of different technical areas. But in a nutshell, one of the things that's been concerning a lot of people is the fact that we have just had an explosion of information in the last 10 years, right? We've developed more, we have created more information in the last, I don't know, 3 or 4 years than all of human existence. It's mind-boggling, it's just one of those, it's one of those weird things where, the numbers stop having any meaning. But where we were doing long-term retention and archiving of this data, it was reasonably straightforward. I mean, you have tape, you've got the hard drives, you've got other types of records that you can keep for the long term. Excuse me. But this type of data, this amount of data, means you got to really start thinking outside the box. You really have to start figuring out, what does it mean to have truly long-term archiving information that's going to last a very long time and going to be retrievable in the future. And so what DNA storage is trying to do is say, look, the DNA molecule can actually act as a storage medium for that long term. Now, it's still in the very early stages. What that means, and if you think about it from a very basic common sense perspective, you have to be able to access that DNA strand. You have to be able to encode it in such a way that's readable in 40, 50 years or 100 years or whatever it is. You have to be able to make the machinery that can do all that work. You have to be able to identify the standards of access, how the software that's supposed to be, what's that going to look like? What do you need? Because you're not going to read DNA the same way that you would read data off of a platter, for example. It's not exactly the block storage that we're used to with an SSD. All of these things need to be defined. And so that's where the DNA Data Storage Alliance, has been starting off. And what SNIA brings to this is kind of the umbrella to be able to do that work in the atmosphere of a storage related context, and we can provide the support necessary for them so that they can focus on the work that they want to do.
Okay, and is it, I mean, I'm been a sort of student of the storage industry for quite a while, and I think holographic storage was sort of out there for a while, and I think I think people were storing on glass as well at one point. I mean, is this one, I'm not sure whether those are still going, but they seemed a bit more pie in the sky. Do you think this is a real concrete thing that's going to happen, or is it still too early to actually work out whether it's going to have the impact that it might have?
Well, anytime you start talking about science fiction like stuff, you always run the risk of it kind of either petering out or hitting a roadblock that you couldn't have anticipated. I too am not sure what happened with holographic storage. I thought it was really interesting as a concept, and I remember they were talking about this back in, I think it was like late 90s, if I remember, they started it. But and there's also molecular storage, which is doesn't sound all that unrelated. I can't say for sure because I really don't know anything about that. But I do think that once you hit a critical mass of interest and the amount of investment that goes into this, not just in terms of money, but human investment and being able to put this together, eventually the need will outweigh the risk, and you'll have to get something to work over time. we just simply don't have the capacity in our existing storage media to handle the influx of data that's coming in for any kind of long-term sense, especially when you start to think about the the kind of skill and charybdis of privacy and retention, and the need to hold on to all this data for regulatory purposes, right? So you wind up with this kind of external influence that would perpetuate this, and an internal motivation to keep going. I think that from what I've seen from the people and the companies that are involved in DNA storage, that there is a critical mass of people who are looking to make this work and work successfully. They've organized themselves in such a way that they're obviously in this for the long haul.
Okay, so that was, I say, one of the main themes, I think, at your Storage Developers Conference. I think the other tracks were around SRM, or dare I say, old friend, storage resource management, although I'm sure there was something new to say about that, and also cloud storage. So can you just give us I think you've just come back from there, but can you give us just a bit of highlights of what those topics brought to light, if you like? Yeah.
Well, yeah, sure. So let's talk about management for a second, because you're right, it is a major issue that needs to be resolved. I think in general, people tend to think of management as an afterthought when they're promoting storage, because let's face it, management really isn't sexy unless you're an administrator and it makes your life easier. The end user is the one that's really going to get excited about this kind of thing, like the same way that an accountant would be excited about a spreadsheet, just to make their lives easier. Well, management in the storage world has been needing to evolve to keep up with the changes that are going on, because what used to be the storage management of choice, which was something called SNIS, it was designed to be around large arrays, centralized storage devices. Well, since that time, we've actually moved into other forms of storage, including disaggregated storage, Ethernet attached SSDs, EBOFs, those kinds of Ethernet bunch of flash, and you've got to be able to provision those somehow. So the DMTF has its Redfish specification for server management, and so SNIA has a relationship with DMTF to create the Swordfish extensions for Redfish. So Swordfish is really Redfish, but with for storage. So if you want to manage these new types of devices, these NVMe Ethernet attached SSDs, or the EBOFs, or the disaggregated storage, Swordfish will allow you to do this without having to reinvent the wheel, especially if you're already using Redfish for your servers. So if you have a storage server, which is basically a box full of storage devices, you can manage the whole thing with one basic management structure. And so we just released the latest version of Swordfish as an ISO specification, and that just happened a couple weeks ago, I believe. So we are heavily promoting the compliance testing programs for Swordfish. I think before we were trying to find the overlapping time, because companies still use SNIS, but the development for SNIS has shifted over to Swordfish, but it's never a clean transition from one to the other. So what we've done this year is like, look, this is where we think we need to go. So we're spending a lot of time promoting and helping people understand how to use Swordfish to get the best management structure for their devices.
Okay, and then cloud storage, again, that's been around for a while. Was there anything particularly new there, or was it just more of the same, dare I say?
Well, I have to confess, when it comes to the cloud storage, it came at a conflict of some other things that I was doing, and I didn't get a lot of chance to really spend it. But the cloud storage is in and of itself is rather vague, right? You've got the storage devices, for instance. You've got the storage access, you've got the storage protocols, object stores, those kinds of things. And I think that one of the things that is kind of striking the cloud storage folks is that it's more than just more performance, right? So the way that the issue with cloud storage in general is that you've got to go through an awful lot of layers to get to the storage from the cloud applications. And what's been happening, especially recently, is that when you wind up with these kinds of applications that don't quite work the way a developer wants it, they just build another layer of abstraction. So I mean, I don't know if you've spent a lot of time going through all of the different layers of how to get a single application in a container to talk to its actual storage, but it's impressive how many layers there are, right? So from an applications perspective, all they want is more raw power, right? They want more raw processing power. And so you eliminate all of the benefits and features that is built into the protocol, that's built into the devices, that's built into the processors. Excuse me. And so what we were talking about in part was, well, how do you capitalize on those, right? You're just ignoring a lot of things that could make your life easier, but most software developers really don't know about it, right? So we were kind of tying the knots together, sorry, tying the strings together, and hopefully aren't knots, but we're trying to get them to start paying attention to the idea that there are things that you can do in storage that you may not necessarily be aware of because it's been hidden from you for so long. And I hope personally that the developers and the software authors and the people who are living in the container world can realize that we've been doing this for a long time and can help. We can actually help you get the performance you need without just waiting for the next Uber processor, from AMD or Intel. So I think that ultimately what you want to do is you want to work smarter, not necessarily work harder. And that's where the cloud storage stuff really tends to shine.
Okay, and I mean, it sounds as if you're very busy as an organization, but are there any other things, sort of on the roadmap we need to be aware of at this moment in time, or with what we've discussed, is that keeping you pretty much fully occupied?
Well, so as the chair, I have a desire to see the organization kind of expand and grow in terms of the strength of its quality of offerings, right? Not necessarily become bigger, but definitely become much more resilient and reliable for those who are depending upon us. So for example, we're talking about the cloud storage stuff. One of the really, really interesting things that's happening is something called SDXI, which stands for the Smart Data Accelerator Interface. And effectively what it does at a very high level is it actually, going back to the cloud storage conversation, it does that very thing that we were talking about with the application being able to use the smarts of the hardware. So let's say, for example, if you were to, let's say you have a storage VM and a regular VM, and you need to move the data from one back to the other. In an environment with a lot of layers of abstraction, you effectively have this pachinko chip that has to go all the way down to the hardware and all the way back up to the other virtual machine. But with SDXI, what you can do is you can tell the hardware using a strict API to effectively do the data movement from one memory location to another privileged memory location. Once you set up the privilege relationship, it'll just happen because the hardware can do it for you. You don't have to go through all of these layers of APIs to get that layer to do this and then that layer to do this and then pass the copy down all the way down to the hardware and then back up again. Just tell the hardware to move it, hardware moves it, and the data, I mean, you can really speed up, and accelerate that data movement. Let's say you want to zero out a location, a memory location. You don't need it anymore. These containers are ephemeral. You want to zero it out and make it nice and secure and start all over from scratch. Tell the hardware to do it. Don't just have to go through and cycle through the software to have it done in that fashion. It can save up an awful lot of time. So there's work that's being done inside of SNIA to help assist that in a vendor neutral way, so that you're not dependent on any one particular type of hardware vendor, any type of software vendor. It's all basically part of an open standard for that kind of data memory movement. So that's one example. Well, we've already talked about Swordfish, we talked about computational storage, we've talked about some cloud, security and data privacy are a big part of it. I think, and energy efficiency as well. So one of the things that's happening all over the world is the movement of government regulations. And as most people know, either intuitively or through experience, and if it's from experience, I share their pain. But government regulations are not always consistent. And so oftentimes you'll come across very strict rules that conflict with each other. So one of the things that we're trying to do, especially with the energy efficiency stuff, and especially with the data privacy and protection, is we're trying to make that approachable for people. So we have something called the Green Storage Initiative, which allows companies to run compliance of their machinery against the the Energy Star requirements that are here in the United States. There are some EU and UK, mostly the EU, not more than the UK, work that is being done for handling data location, where the data actually gets stored, how it gets stored, what the energy needs to be for those. We're working with those different governments as well as the United States to make sure that it's easy for vendors to comply, or easier. They'll always build a more interesting regulation. But those are the kinds of things that we're doing that aren't necessarily sexy, but the penalties could be rather severe.
Yeah, okay. And you mentioned of energy efficiency. I mean, the world is heading towards net zero, at varying paces depending where you are, what industries. What I suppose responsibility do you think SNIA has as an organisation? You mentioned the energy efficiency, but that sounds as if, at least at one level, you're responding to strict sort of government requirements. But more generally, the industry, are you helping them move towards that sort of target? And in terms of data, I know obviously your vendors are there to provide storage, and there's more and more data, as you discuss, being produced, ridiculous amounts. Do you think you have any sort of requirement, obligation to start some kind of debate or enter into the debate as to, should we just be storing all this information forever and ever, or do we actually need to start thinking about the life cycle of data a bit more seriously? I mean, just some thoughts on what your association's role is in the sustainability debate.
That requires a shift in our focus a little bit, and it's a shift we've been talking about. So from my perspective, I have always taken the stance that as the quote unquote storage experts, I think we have a moral responsibility for being able to lend that experience into the world where these types of regulations can have deleterious effects on whether or not you're storing the data, or whether or not you're storing the data properly. And I do think that different governments may have the best intentions, or they may not. You never really know. But a lot of them are making decisions that don't make an awful lot of sense from a technical perspective. And I think that SNIA is an organization that has a moral duty to be a friend of those courts, to be able to offer some recommendations and some guidance. We're not a lobbyist organization, so we don't go onto K Street, and we don't meet with anybody in the governments, but we do send out statements and white papers and position papers for certain things when appropriate. We've done a few of them this summer, as a matter of fact, for some of the security things that have come out with regards to some of the changes that have been going on. For in standards, it's really kind of funny because you have this overarching umbrella of accountability, right? So when you talk to somebody who's in standards, they get very mired in the word shall or the word should, and it seems like minutia to the layperson, but that becomes the basis for a lot of this regulation, right? So if the regulation says you shall do something, or you should do something, or you must do something, you're never going to see something like, well, you may do it. It doesn't really quite work out very well when you start using the word like, yeah, you can, or you may. You may find the language every once in a while slip through, but very rarely. But our role is to make that be nice and clear, right? Because if the government resolves something, the government needs to know what's doable. You can't just say do this and have it be an impossibility. At the same time, when they do pass these kinds of regulations, we need to tell our members, this is what it means. This is how you actually start applying this. So we act as kind of an intermediary of information. And no, I have to confess, it's not sexy. It's not the kind of thing that attracts a lot of people. But it does have a fundamental purpose that needs to be an ongoing solution.
And sort of out of the pandemic, I mean, sustainability, I'm not saying it came out of the pandemic, but it's become a bigger topic, I suppose, since similarly the supply chain has come under sort of intense scrutiny. And some people, I guess, maybe are hoping once the situation in Eastern Europe, etc., calms down, things will go back to normal, whatever that might mean. But do you think supply chains, your members are already or need to start reevaluating, where they're getting their resources from? Or, as you say, do you think if they're sit it out for another 6 months, they can, everything's back to normal? Or do you think it's a long-term issue that needs addressing?
I would caution anybody into thinking that they can wait and expect things to go back to normal, because what constitutes normal nowadays, it's not the way it was 2 years ago. We have the geopolitical impact on supply for data and communication has radically changed in the last 3 years. So the Eastern Europe situation is actually a little bit more dire than people realize. There are a lot of software houses in the Ukraine. There's a lot of information that are coming out of that area of the world. Even Russia itself has offered considerable amounts of positive technology contributions into the industry. There's China, there's Taiwan, there's the global impact of the tensions going on there. There's the we still have the some of the sanctions on Chinese companies in the United States. We have new regulations about what can and can't be sent into and out of the Chinese territories. So that's not going away in 6 months. I think anybody who thinks that it's going to take a 6-month hiatus and then have everything go back to perfection is probably fooling themselves. What I think we have to do is we have to we can't just try to accept all this in one lump sum. We have to be vigilant. Excuse me. We have to be diligent and vigilant. Say that 3 times fast. We need to be aware of what's happening in the tensions in India and Pakistan, and all of these things have a much greater impact all the way as into Poughkeepsie, right? I mean, it's one of those things, or Leeds. Either way, it's going to be impacted somewhere. Whether it's going to be at the at the service level, it's going to be impacted at the price level. It's going to be impacted on the the regulation level. I think one of the other things that's happening too is the content of the data is starting to get more scrutiny. There are things that are happening with unelected non-governmental organizations that are starting to make people question what kind of data can be sent to whom and when, who should be able to have it, who shouldn't be able to use it. Those all have really profound impacts. So I honestly think that we don't have all the answers. I'm not pretending that we do, but I do think that you need to have somebody you can ask a question to, somebody who is also taking ongoing attention to what's happening. Because if you're not careful, you could wind up being on the business end of a hissy fit, and I don't think anybody really wants that.
Okay, and then maybe just to sort of as we finish, the storage industry more generally. I mean, I've sort of followed it on and off since the early days of Fibre Channel, which is a wee while ago, and there's plenty of names that were, like, if you like, the bedrock of the industry then and are no longer around. I'm just wondering, it's a classic, I guess, technology that there were a lot of people in it early, then it's consolidated. Do you worry at all that the consolidation has perhaps gone too far and that the gene pool, if you like, is too small, so there's not enough innovation? Because whenever somebody does something clever, it seems to be hoovered up, dare I say, by one of the larger organizations. Or do you think the industry is very healthy, and as we've discussed earlier, there are some innovative ideas going on, and therefore all is good in the garden?
Well, I don't know how good the garden is, but I think that if you look at the history of technology, you'll see that there's a bit of an accordion effect, right? Expansion and contraction has been normal, and it's been going on, ever since the days of UNIVAC, right? So, if you follow through the history of any technology, all the way back, if you want to go all the way back to the telegraph, it's exactly the same thing. The history has been consistent. Same thing with hardware and software. There was a period of time not too long ago when people said that hardware was completely irrelevant. All you needed to do was software. And now, where has really the innovation come through? hardware. We now have, the Universal Chiplet consortium that started up. We've got SNIA, we've got Envium Express, we've got CXL, which is really taken the server world by storm. You have all of these technologies that are hardware oriented, hardware related, that will make the software better. And then the software will improve as well. And then the software will get better, and we'll start to eliminate some of those layers of abstraction because that got too big, right? The software component is, if you were to look at a stack diagram of all the latency, software is huge, right? And pretty soon people want to get better performance. So they reduce that software and they start focusing on the hardware. The accordion starts to come back. As long as the accordion is moving, we're healthy. Right? It's when people start to artificially try to stop it, then things get into trouble. And from SNIA's perspective, we are perfectly happy to play the accordion. We are happy to go ahead and encourage the development where it needs to be, like the DNA, data storage lines, right? Perfect example. That is real, true, innovative thinking. Right, is truly thinking outside the box, and literally, as it turns out. So I think that there's always going to be somebody who wants something more or something better, something more efficient, something less costly, and they're going to have an idea to do it. Some of them will win, some of them won't. And by winning, I mean just be used. Right? It doesn't have to be the best. It doesn't have to be the greatest. It just has to be, something that people are working on. From our perspective, we're perfectly happy to be home for those kinds of things, and that's, I think, where we're going to be focusing in the future.
Okay, and then maybe just finally, in terms of the end user, I always feel slightly sorry for them because they're getting bombarded with all these great new ideas and things going on. They're one day being told to be on the premise, and then the next go in the cloud, and all the. I know it's very difficult to limit yourself maybe to one or two, but if you had a couple of pieces of advice to end users faced with this enormous portfolio of storage technologies and stuff, where do you think they should concentrate to get the quickest results, or what do they need to be looking at, do you think, to improve their storage performance?
Well, rule number one, don't panic and bring your towel. Number two, SNIA has been doing an awful lot of work over the last several years to try to break a lot of this down into plain English. So we have probably a library of hundreds of hours of plain English content that they can go to by going to the SNIA website, or because we have a YouTube video, you can go on YouTube and go to our YouTube channel too. It's vendor neutral, it's technology neutral, which means that there's no promotion of any one vendor over another or any one technology over another. So if you want to find out about the pros and cons of Fiber Channel, which still very strong storage technology, you can do that. If you want to find out about XPUs, which are brand new and very confusing to a lot of people, SmartNICs, computational storage, these are just some of the more recent ones. But we also go back to the basics, right? If you don't know what RAID is or what RAID means, if you're not sure what an initiator or a target is, you just want to get started, we have those kinds of things as well. We have a series called Everything You Wanted to Know About Storage, but We're Too Proud to Ask. So everything from the absolute basics to the very new complex topics, we do an awful lot of education that is just freely available for people. All they have to do is look. And so that we're going to continue to do that. It's a major pillar of our mission.
Okay, well, I've taken up a lot of your time and I really appreciate it. You've given us some fascinating insights. So thank you very much indeed for being with us. Thank you.
Thank you for the invite.